Hello dear learner, welcome back to the Zoom Chemistry Hub. Today in this video we will discuss and learn the most important questions regarding the MCQs of colligative properties from the chapter solution. So first question, which of the following is not a colligative properties? Option A, relative lowering of vapor pressure. Option B, boiling point elevations. Option C, heat of neutralization. Option D, freezing point depressions. As we know that the colligative properties depends on the number of solute particles, not their nature. So we can discuss each option one by one. First, the relative lowering of vapor pressure. The relative lowering of vapor pressure depends on the number of solute particles. So it is the colligative properties. Next is the boiling point elevation. Boiling point also depends on the number of solute particles directly. So it is also the colligative properties, that is the option B is also the colligative properties, the boiling point elevations. Similarly, we will take the option D, freezing point depression. The freezing point also depends on the particles number, not their nature of the solute. So it is also the colligative properties. And here the option C is correct, which is not colligative properties, that is the heat of neutralization. We know that heat of neutralization is a thermodynamic properties, so it is not a colligative properties. So here the option C is correct according to the questions. Next question, which solution will have the highest boiling point? Option A, 1 molar glucose solution. Option B, 1 molar sodium chloride solution. Option C, 1 molar potassium sulfate solution. And option D, 1 molar aluminum trichloride solutions. For solving this question, to identify the correct option, we know that the boiling point elevation is directly proportional to the want-of factor multiplied by the molarity. That is the B, boiling point elevation is directly proportional to IM. And the want-of factor for option A, that is the 1 molar glucose, we know that non-electrolyte have want-of factor have 1, so its I value is 1. Similarly, option B, 1 molar sodium chloride solution, we know that when sodium chloride will ionize or dissociate into their ions, so their dissociated ions are 2 in number. So here the I value for this is I is equal to 2, that is sodium ion and chloride ion, 1 sodium ion and 1 chloride ion, so its I value is 2. Similarly, for 1 molar solution of potassium sulfate will ionize into 2 potassium ion and 1 sulfate ion, so the total number of ions are 3, so here the value of I is equal to 3. Similarly, the option D, that is the 1 molar solution of aluminum trichloride, when aluminum trichloride ionize into their ions, so aluminum trichloride ionize into 4 ions, 1 is aluminum ion and 3 is chloride ion, so the maximum number of ions here in this, that is I is equal to 4. So here the option D is correct, that is the solution which will have the highest boiling point, that is the Option D, 1 molar aluminum trichloride solution have the maximum effect of boiling point. So in short, the greater the want of factor, greater the highest the boiling point of the solution. Next question, question number 3. Elevations of boiling point is directly proportional to option A, normality of the solution, option B, molality of the solution, option C, volume of solvent, option D, surface area of solution. Now we will explain all these. First, option A, normality. Normality is only for acid-base solution, and we do not use the normality here in this case, so it is incorrect. Next, option C, we will take the volume of solvent. The volume of solvent does not directly affect the property or the elevation of the boiling point directly, so it is also the incorrect. Similarly, the option D is the surface area of the solute. The surface area of the solute affect the rate of the boiling point but not properly itself, but not directly affect the boiling point of the solute, so it is also the incorrect. And here the correct option is option B, that is the molality of the solution, that is del T into B is equal to K and B multiplied by M, that is the molality. So the elevations of boiling point is directly proportional to the molality of the solution, so the option B is correct. Next question, which of the following does not affect the colligative properties? Option A, degree of dissociation, option B, number of ions, option C, nature of solute, option D, molar mass of solute. Now we will explain one by one. First, the degree of dissociation. Degree of dissociation affect the effective particles number, not affect the colligative properties, so the option A is incorrect. Similarly, option B, number of ions. We know that the colligative properties depends on the number of ions, so it will strongly affect the number of ions affect the colligative properties. So according to the question, this option is also the incorrect. Similarly, we take the option D, that is the molar mass of the solute. The molar mass of the solute, we can calculate it directly from the colligative data, so the molar mass of the solute is also the incorrect according to the questions. And here the option C, which is a correct option, that is the option C, nature of the solute. We know that the colligative properties depends on or affected by the degree of dissociation, number of ions and the molar mass of the solute, and it does not affected by the nature of the solute. So here the option C is correct, that is the nature of the solute, because the type does not matter, only the number matter. So the option C is correct according to the question. Next question, question number 5. Osmotic pressure of a solution is given by which expression? Here we have 4 expressions. that is A, B, C and D. Now we will explain these four expressions one by one. In the option A, the osmotic pressure is equal to IMRT. Here you can see the capital M is the molarity, but osmotic pressures are affected by the concentration, and here you can see there is no concentration in this expression. So the option A is incorrect. That is, the osmotic pressure is equal to IMRT. This expression is not correct. Similarly, option B. Here you can see that the osmotic pressure also related to the want-off factor, that is I. Here in the option B, the want-off factor is missing, so it is also the incorrect. Similarly, option C, that is osmotic pressure is equal to IRT. We know that the osmotic pressure also depends on the concentration, so here the concentration are also the missing like the option A, so it is also the incorrect. And the last option, option D, that is osmotic pressure is equal to ICRT. It is the correct option. Here the I is the want-off factor, C is the concentration, R is the gas constant and T is the temperature. So the correct and complete expression for the osmotic pressure is osmotic pressure is equal to ICRT. That the option D is correct according to the question. That's for all today the learner. Don't forget to like, subscribe and share this video with your friends and fellows. Thanks for watching.